problem, we're going to be graphing this radical function and then answering several questions afterwards. To graph the radical function f of x using your calculator, turn it on, go to your y equals, and you can type the equation in 2 plus. Now the square root key is right above the x squared. It's the second function of that key, so hit second x squared to get the square root. It's giving me a left parenthesis so that I can type in 5x plus 25 and then do a right parenthesis to communicate to the calculator that the whole expression is under the radical. You want it to know that not only the 5x but the plus 25 as well is under the radical. So everything in the parentheses is under the radical. I'm going to graph this in a standard window by pressing the zoom key and selecting option 6, which is zoom standard. So I'm going to press 6. This graphs it for me in a standard window from -10 to 10 on the x and the y axis. So I'm done with the first part. The second part says identify the horizontal intercept as an ordered pair. If it does not exist, write D and E. So the way this looks is it looks like there is no horizontal intercept. It looks like the graph never crosses the horizontal axis. It turns out that this is the case, but looks can be deceiving. So I'm going to do the algebra on this. I'm going to go over here. Here's my function. And one thing I know about horizontal intercepts is this, that if you were to draw a graph just roughly, any point on the x-axis, the horizontal axis, if you were to plot it, they would have different inputs, say, but one thing I know about all points on the x-axis is the output is 0. So my job is to find the input that makes the output 0 there. So I'm going to go up here, and since I know my output has to be 0, I'm going to replace f of x, all of that stuff right there, with the number 0, and I'm going to proceed to solve this equation. So I believe this is one of those things that when you do the algebra correctly, you get an answer, but it just turns out that you have what's called an extraneous solutions. I don't know if you've ever seen one of these before, but you can actually do the algebra correctly and have it come out so that it doesn't check. So I'm going to solve this very carefully. First by subtracting 2 on both sides of the equation. 0 subtract 2 is -2. And on the right hand side you have a 2 subtract 2. That simplifies down to be 0. I don't need to write that. So I'm left with radical 5x plus 25. And because I can color code this, I really suggest you recopy this so things don't get messy. But since I'm going to color code this, you can see what I did to change this step. I need to get rid of this square root operation, and the way to eliminate a radical is to square it. Since this is the square root, I'm going to induce the inverse operation, which is squaring. But what you do to one side, you must do to the other. So on the left-hand side, I'm going to get -2 squared, which means, -2 times -2, that's +4. On the right-hand side, just as I said, squaring and square roots simplify out. They are inverse operations, leaving me with just 5x plus 25. Everything seems to be going well. I would then subtract 25 on both sides, and then over here, 4 take away 25 is -21, and on the right-hand side, you have your 5x. The 5 is being multiplied, so the inverse operator there would be division by 5. And this simplifies down to be 1. So 5 divided by 5 is 1. So you have 1 times x is equal to -21/5. And if you didn't check it, you'd think that everything's fine and that we actually have a vertical intercept. In fact, I would think that the vertical intercept would be over here at a -x value at that point. So, but the graph is deceiving, so it looks like maybe that could be the case. But you really should see that -25 actually doesn't satisfy this equation here. So this was the original equation, and we were trying to find the x value that made all of this come out to be 0. So what I'm going to do is I'm going to do the part of the problem that you probably don't like to do, but to check it to see if it works. So here it all is. Oops, I copied that wrong. The 2 is on the outside. So what I'm going to do now is I'm going to check it by plugging in my solution. So where I see the letter x here, I'm going to replace it with our solution, -21/5. So -21/5 goes right here. And we're going to see if this is a true statement or not. Does this all come out to be 0 or not? So here we have 5 being multiplied, 5 being divided. So 5 divided by 5 is 1. Those cancel. And after that, I get radical. What survives here is the 25 and the -21. So you have a -21 plus 25, that's 4. The square root of 4 is 2. and 2 plus 2 is 4, which is most decidedly not 0. So my point is that this is the only candidate solution for this equation, and it didn't work. So what that means is there's no x value that satisfies this equation, so there's no x value that makes the y value 0, which means there's no horizontal intercept, and that's why in the calculator graph here you see it not crossing. So all of that to simply state that there's no horizontal intercept. So I'm going to write DNE there. Now to identify the vertical intercept, that's actually a lot easier. I'm going to clear the slate here. Now finding the vertical intercept, remember the vertical axis is your y-axis, so the explanation is similar but it just works differently. The vertical axis is this, that would be the y-axis, and any point on the y-axis has the x-coordinate being 0, not the y. So I'm going to do something similar up here as I did before, but instead of replacing the output with 0, I need to replace the input with 0. So I would have x being replaced with 0, so I'm finding f of 0. And you could do this very easily on the calculator, but I think the arithmetic is so easy, I think you should just do it because you could probably do it in your head. So 5 times 0 is 0. 0 plus 25 is 25. The square root of 25 is simply 5. And don't forget that you're adding 2 over here. So it comes out to be 7. So f of 0 is 7, meaning if you plug in 0, you get out 7, and that would be my vertical intercept. This would be very easy to do on the graphing calculator by simply pressing trace. And actually the default on the calculator when you hit trace is to start on the y-intercept, so it's 0, 7. So hopefully you're still with me. And so left parenthesis 0, 7, right parenthesis. Now I need to find the domain, but I've done a lot of the hard work. I know that my graph goes as far to the left as this and goes to the right, but I don't know if we ever really nailed down exactly what that leftmost point was. So to find the leftmost point on the calculator, it certainly looks like it's negative 1, 2, 3, 4. Looks like negative 5 is the leftmost intercept. What you need to do is simply figure out the domain of the function here by taking the radicand 5x plus 25. Perhaps I'll clear the slate here because we've got all this other stuff here. To find the domain by hand, I guess the easiest way to do that is to simply write down the statement of what you want to happen. Things will work out very well as long as your radicand, this is your radicand here, to write it down and simply state that things are going to work out nicely. We're going to get valid real number outputs as long as the radicand is positive, which means it's greater than 0, or it actually can be equal to 0. So I simply need to solve this inequality. As long as that happens, as long as this thing, the radicand, is positive or 0, you're going to get real answers out of it. Square root of 0 would be 0, which is an answer. The square root of any positive number would give you a real answer. It's just when this thing comes out to be negative that is a troubled area. When this comes out to be negative, when you take the square root of a negative, you get what's called a complex number, and that's exactly what we're trying to avoid. So the idea is to simply restrict the domain in this way. So to make a long story short, you subtract 25 on both sides, and I would get 5x is, positive 25 subtract 25 is 0, and then 0 subtract 25 is negative 25. This is an inequality, and I'm dividing, but the rule is you only switch the symbol if you're dividing by a negative, and that's not the case. I'm dividing by a positive, so the fact that this is negative is irrelevant. It's what you're dividing by. So I divided by a positive, no need to switch this. 5 divided by 5 is 1, so you have 1x, is greater than or equal to negative 25 over 5 is simply negative 5. So there's my domain. As long as x is bigger than or equal to negative 5, and you can see that on the graph, it just can be deceiving. If I typed in trace negative 5, you would see the leftmost point there. So my domain is going to be such that the furthest to the left that the graph goes is negative 5, but it goes to the right forever. It just keeps getting bigger. Your x values can get as big as you'd like in the positive direction, so we call that positive infinity. So the domain on this one is going to be the smallest x value that my function allows is 5, and it can include, negative 5, and it can include the negative 5. So if you plug in negative 5, things will work out. So we're going to put a bracket there to indicate that negative 5 is okay, In fact, you saw that on the graph that when we typed in -5, we got a valid output there, namely 2. And then comma, and then because the graph went to the right forever, we're going to put positive infinity, and you don't reach infinity, so we always put a parenthesis there. So as far as the domain, it's left bracket, that's the key just to the letter P on the keyboard, -5, comma. The way to type infinity is 2 lowercase o's, not zeros. Use 2 lowercase o's, no spaces, and then there was a parenthesis around that. So I answered the first 3 questions. The other one left is to graph the function by plotting the leftmost or rightmost point, depending on the domain, and one other point. So we have a leftmost point of 5, 2, and we can pick any other point to the right, but you might as well use the vertical intercept since we already know that point was 0, 7. So I'm going to go here and scroll down, and I'm going to graph it using this. I guess there's only one icon down here, so you don't really need to select it. And the leftmost point was -5, 2. I'm going to click and hold that down, and then it said to plot one other point. So plot the leftmost point, and then one other point was 0, 7, I believe it was. And then just let go, and that should be the answer to the problem. Let me check real quick because I talked so much I couldn't remember if it was 7. Yeah, indeed, the vertical intercept was 0, 7. I've forgotten already. And that's basically how you do the problem.